Question 1. In the context of a development team transitioning a legacy monolithic application to containers, which key advantage of containers over virtual machines primarily supports faster deployment and resource efficiency? A. Containers share the host OS kernel, allowing multiple isolated applications to run with less overhead than virtual machines. B. Containers virtualize hardware resources, providing full OS environments to each application instance. C. Containers require dedicated hypervisors for resource allocation, increasing system isolation. D. Containers use traditional boot sequences similar to VMS, ensuring compatibility with software. Answer. Correct answer. A. Explanation. Containers operate by sharing the host operating system kernel, which allows them to be lightweight and start quickly. This shared kernel model reduces overhead significantly compared to virtual machines that each run a full OS instance. As a result, containers provide faster deployment, better resource utilization, and agility in modernizing applications. This fundamental architectural difference is why containers are rapid scaling and continuous delivery environments. Question 2. Given the circumstances of a team designing a Kubernetes-based platform, how does the declarative configuration pattern enhance cluster management compared to an imperative approach? A. Declarative configuration requires manual command execution for each change, increasing operational overhead. B. Declarative configuration enables users to specify the desired system state, allowing Kubernetes to reconcile actual state automatically. C. Declarative configuration mandates real-time scripting, limiting automation capabilities. D. Declarative configuration prevents rollback to previous states, complex error recovery. Answer. Correct answer. B. Explanation. Declarative configuration allows users to define the desired end state of the system, such as the number of replicas or service endpoints. Kubernetes then continuously works to reconcile the actual state with this desired state, automating management and reducing manual interventions. This approach simplifies operations, supports version control of configurations, and enables automated rollback and recovery. Modern container orchestration. Question 3. Considering the evidence from recent deployments, why is the use of a Kubernetes ingress controller critical for exposing containerized applications externally? A. Ingress controllers dynamically allocate storage resources for pods. B. Ingress controllers provide a declarative way to configure pod scaling policies. C. Ingress controllers manage external HETs to traffic routing and load balancing to services inside the cluster. D. Ingress controllers automate container image updates within the cluster. Answer. Correct answer. C. Explanation. The Kubernetes ingress controller serves as the gateway for external clients to access services running inside the cluster. It manages HE traffic, enabling sophisticated routing rules, SSL termination, and load balancing. This abstraction allows operators to expose multiple services through a single external IP, improving security and operational simplicity in containerized environments. Question 4. Based on the information provided about VMware Tanzu editions, what distinguishes Tanzu Standard from Tanzu Basic in terms of features and use cases? A. Tanzu Standard primarily supports legacy virtual machines without Kubernetes integration. B. Tanzu Standard includes advanced Kubernetes lifecycle management features and enterprise integrations beyond Basic. C. Tanzu Standard is limited to single-node Kubernetes clusters for development purposes. D. Tanzu Standard removes support for container orchestration to focus solely on POS capabilities. Answer. Correct answer. D. Explanation. Tanzu Standard builds upon Basic by providing advanced Kubernetes lifecycle management, enhanced security, and broader integrations suitable for production environments. It does not remove container orchestration capabilities. Rather, it extends them, enabling enterprises to better manage Kubernetes clusters at scale with integrated tools and support. Thus, Tanzu Standard offers a more comprehensive modernization platform compared to Basic. Question 5. While examining the role of Tanzu Mission Control (TMC), how does TMC facilitate multi-cluster Kubernetes management across diverse infrastructures? A. TMC allows centralized policy enforcement and observability across clusters regardless of their location or provider. BEMC is designed solely for monitoring single-node Kubernetes clusters. CTMC replaces the need for kubectl by abstracting all cluster operations into graphical workflows. DTMC requires direct integration with each container image registry to manage images. Answer. Correct answer. A. Explanation. Tanzu Mission Control provides a centralized control plane that enables users to manage multiple Kubernetes clusters, whether on premises, in public clouds, or at edge locations. It offers consistent policy enforcement, access control, and observability tools, facilitating secure and streamlined operations across diverse environments without needing separate management consoles for each cluster. Question 6. From the perspective of software development, how does continuous integration, continuous deployment, SICT pipelines improve containerized application delivery in VMware Tanzu environments? A. SICT pipelines introduce manual intervention points that slow down the release process. B. SICT pipelines automate build, test, and deployment stages, enabling rapid and reliable application updates. C. SICT pipelines are incompatible with container image registries and require external artifact storage. D. SICT pipelines restrict deployment to only non-production Kubernetes clusters. Answer. Correct answer. B. Explanation. SICT pipelines automate the entire process of building, testing, and deploying applications, which is essential in modern containerized environments. By integrating with container image registries and Kubernetes clusters, SICT accelerates delivery cycles, improves quality through automated testing, and reduces human error, thereby supporting agile practices in VMware Tanzu platforms. Question 7. Illustrated by real-world microservices deployments, what is the principal advantage of employing a service mesh such as Tanzu Service Mesh within Kubernetes environments? A. Service meshes eliminate the need for network security policies by default. B. Service meshes automate inter-service communication with observability, routing, and security features without modifying application code. C. Service meshes replace Kubernetes native services for pod discovery. D. Service meshes restrict traffic flow exclusively to internal cluster namespaces. Answer. Correct answer. C. Explanation. Tanzu Service Mesh adds a dedicated infrastructure layer that manages service-to-service communication transparently. It provides advanced features like traffic routing, retries, observability, and security policies without requiring developers to modify their application code. This decoupling facilitates secure, resilient, and observable microservices communication essential in modern cloud-native applications. Question 8. When analyzing container image management, why is an image registry considered a critical component in application modernization workflows? A. Image registries function as local build servers for container images. B. Image registries provide centralized version storage and distribution of container images accessible by Kubernetes clusters. C. Image registries handle runtime scaling of pods automatically. D. Image registries eliminate the need for container orchestration by packaging applications as EMS. Answer. Correct answer. B. Explanation. An image registry serves as a repository where container images are stored, versioned, and distributed to Kubernetes clusters during deployments. Its centralization enables consistent, repeatable application delivery, supports image vulnerability scanning, and integrates seamlessly with SICT pipelines. Effective image registry management is essential for secure and scalable modernization workflows. Question 9. In light of recent developments, how does infrastructure as code IaaC contribute to the reliability and reproducibility of Kubernetes cluster provisioning in VMware Tanzu environments? A. IaaC requires manual script execution for each deployment step, increasing complexity. B. IaaC uses declarative configuration files to automate cluster provisioning, reducing human error and drift. C. IaaC eliminates the need for Kubernetes API interactions. D. IaaC only applies to virtual machine provisioning, not Kubernetes clusters. Answer. Correct answer. A. Explanation. Infrastructure as code automates the provisioning and management of infrastructure through declarative configuration files or scripts, allowing clusters to be provisioned consistently and reproducibly. This approach minimizes manual steps, reduces configuration drift, and ensures that Kubernetes environments are version controlled and auditable, which is crucial in VMware Tanzu's modern application lifecycle management. Question 10. Throughout the course of troubleshooting, a failing Tanzu Kubernetes grid cluster, which kubectl command is most effective for diagnosing pod-level issues by providing real-time logs. A. Kubectl describe node. B. Kubectl logs. C. Kubectl get services. D. Kubectl config view. Answer. Correct answer. B. Explanation. The kubectl logs command retrieves real-time output logs from a specific pod's containers, allowing administrators to diagnose runtime errors, application crashes, or configuration problems directly. These logs are invaluable for troubleshooting application behavior in Tanzu Kubernetes grid clusters, enabling faster identification and resolution of issues affecting pod health and performance. Question 11. When considering Kubernetes pods, which statement best describes their fundamental purpose in application deployment? A. Pods are a set of physical servers dedicated to container execution. B. Pods serve as persistent storage volumes for containerized applications. C. Pods provide an isolated network namespace shared among containers, facilitating co-located container execution. D. Pods are the smallest deployable units in Kubernetes that encapsulate one or more containers sharing storage and networking. Answer. Correct answer. D. Explanation. Pods are the fundamental Kubernetes units that encapsulate one or more tightly coupled containers, which share the same network IP and storage volumes. They enable related containers to be managed, scheduled, and deployed together, supporting multi-container application patterns while providing isolation from other pods within the cluster. Understanding pods is key to managing container orchestration effectively. Question 12. In the context of container orchestration, how does Kubernetes enhance the deployment and scaling of containerized microservices compared to manual container management? A. Kubernetes automates deployment, scaling, and healing of containers based on declarative specifications, reducing manual intervention. B. Kubernetes requires manual intervention to schedule and scale containers across nodes. C. Kubernetes replaces container images with virtual machines for improved security. D. Kubernetes eliminates the need for container registries by embedding images in the cluster. Answer. Correct answer. A. Explanation. Kubernetes provides a powerful orchestration platform that automates the lifecycle of containerized applications. By using declarative configuration files, users specify desired states like replica counts and resource limits. Kubernetes continuously monitors the cluster, automatically scaling, rescheduling, or healing containers as needed, which significantly reduces operational complexity and application availability. Question 13. Based on the information about Tanzu Build Service, which best explains its role in automating application container image creation, a Tanzu Build Service provides runtime monitoring and alerting for container clusters. B. Tanzu Build Service manages multi-cluster policy enforcement across Kubernetes deployments. C. Tanzu Build Service automates the creation, update, and maintenance of container images using source code and buildbacks. D. Tanzu Build Service orchestrates pod-to-pod communication via service mesh capabilities. Answer. Correct answer. C. Explanation. Tanzu Build Service automates the process of building container images directly from application source code by leveraging cloud-native buildbacks. It continuously monitors source code and dependencies for changes, triggering automated rebuilds and ensuring images are always up to date and secure. This automation streamlines continuous delivery workflows and reduces manual image management overhead. Question 14. With respect to configuration management in Kubernetes, what distinguishes secrets from config maps? A. Secrets store configuration data in plain text for easy access. B. Secrets provide a secure way to store sensitive information like passwords or keys, whereas config maps store non-sensitive configuration data. C. Config maps encrypt all stored data by default, whereas secrets do not. D. Secrets are used exclusively for cluster metadata and not application configuration. Answer. Correct answer. B. Explanation. Kubernetes secrets are designed to securely hold sensitive information such as passwords, tokens, or certificates and are encoded to prevent accidental exposure. Config maps, on the other hand, are intended for storing general, non-confidential configuration data such as environment variables or configuration files. This distinction supports best practices for application security and configuration management in Kubernetes. Question 15. Throughout the course of adopting VMware Tanzu Observability, what unique value does this tool provide in monitoring modern cloud-native applications? A. It functions only as a log aggregation platform without real-time metrics. B. It provides centralized observability with full-stack metrics, tracing, and logs correlated to Kubernetes clusters and services. C. It replaces Kubernetes native Prometheus monitoring capabilities entirely. D. It only supports monitoring of legacy virtual machine workloads. Answer. Correct answer. D. Explanation. Tanzu Observability is designed specifically for cloud-native environments, integrating metrics, logs, and traces across Kubernetes clusters and microservices. It provides comprehensive observability to detect, diagnose, and optimize applications running in modern infrastructures. It does not focus solely on legacy VMS, but targets dynamic, containerized workloads critical to application modernization. Question 16. Given the circumstances of using Tanzu Kubernetes to Git TAG, what primary benefit does TAG offer for enterprise Kubernetes deployment? A. TAG provides a simplified, validated Kubernetes distribution optimized for consistent multi-cloud and on-premises environments. B. TAG is a proprietary container runtime replacing Docker and container. C. TAG automates application code refactoring for modernization. D. TAG replaces the need for Kubernetes API servers by providing a custom control plane. Answer. Correct answer. A. Explanation. Tanzu Kubernetes Grid offers a curated, enterprise-grade Kubernetes distribution that VMware supports and optimizes for hybrid cloud deployments. TAG ensures consistency across on-premises and public cloud environments, simplifies lifecycle management, and integrates with VMware infrastructure tools, allowing organizations to confidently adopt Kubernetes at scale. Question 17. For the purpose of application modernization, how does microservices architecture improve scalability compared to monolithic applications? A. Microservices consolidate all functions into a single deployable unit to simplify scaling. B. Microservices decompose applications into loosely coupled, independently deployable components, allowing targeted scaling based on demand. C. Microservices require all components to scale simultaneously, increasing resource use. D. Microservices mandate using virtual machines instead of containers for better isolation. Answer. Correct answer. B. Explanation. Microservices architecture breaks down applications into smaller, autonomous services that communicate over APIs. Each service can be scaled independently according to workload, optimizing resource usage and enabling more flexible, resilient scaling strategies than monolithic architectures, which scale as a single unit regardless of internal demand. Question 18. In what ways can infrastructure as code IaaC practices improve security posture within VMware Tanzu environments? A. IaaC encourages manual updates of infrastructure to address vulnerabilities. B. IaaC enables version control and automated auditing of infrastructure configurations, reducing misconfiguration risks. C. IaaC eliminates the need for network security policies by automating cluster deployment. D. IaaC restricts Kubernetes cluster access to administrators only without role-based access control. Answer. Correct answer. C. Explanation. Infrastructure as code allows infrastructure to be defined as code, enabling version control, peer review, and automated testing of configuration changes. This reduces human errors and misconfigurations, which are common security risks. By codifying network policies and security settings, IaaC helps maintain consistent, auditable, and compliant environments in VMware Tanzu. Question 19. Considering troubleshooting methods for Tanzu Kubernetes clusters, what is the most effective approach to investigate a deployment failure? A. Restart the cluster control plane nodes immediately to reset all components. B. Review pod logs using kubectl logs and examine event details with kubectl described to identify error causes. C. Disable all network policies and retry deployment to isolate network issues. D. Delete and recreate the cluster to resolve unknown failures. Answer. Correct answer. D. Explanation. Effective troubleshooting relies on gathering diagnostic information such as pod logs and event details to pinpoint the root cause of deployment issues. This targeted approach preserves cluster state and aids in root cause analysis rather than disruptive resets or recreations. Systematic log and event review is the best practice for resolving Kubernetes deployment problems. Question 20. Under the assumption that a team wants to implement a platform as a service PaaS model using VMware Tanzu, which characteristic best describes PaaS benefits? A. PaaS provides infrastructure management but requires manual application deployment. B. PaaS offers an abstracted environment where developers deploy applications without managing underlying infrastructure. C. PaaS limits application scalability by requiring physical server allocation. D. PaaS is primarily focused on providing container image registries without orchestration. Answer. Correct answer. A. Explanation. Platform as a service delivers a managed environment where developers can focus on building and deploying applications while the platform handles infrastructure provisioning, scaling, and maintenance. This abstraction accelerates development cycles and reduces operational burdens, fitting well with VMware Tanzu's goal of streamlining application modernization workflows. Question 21. In light of recent developments, how does Tanzu Service Mesh enhance microservices communication security within Kubernetes clusters? A. By disabling all network traffic between pods except or API gateway communications. B. By providing encryption, identity-based authentication, and fine-grained traffic control without modifying application code. C. By replacing Kubernetes services with proprietary networking protocols. D. By enforcing network isolation through manual firewall rules between namespaces. Answer. Correct answer. B. Explanation. Tanzu Service Mesh integrates a transparent infrastructure layer that encrypts inter-service communications, applies identity-based authentication, and enables granular traffic policies. This security model operates independently from the application code, allowing developers to focus on functionality while the service mesh ensures secure, observable, and reliable communication between microservices. Question 22. Given the circumstances of managing a Kubernetes cluster's health, what is the best practice for using Tanzu Mission Control to maintain cluster compliance? A. Manually inspecting each cluster node's resource usage without automation. B. Centralizing policy enforcement and continuous compliance checks across clusters via TMC's governance capabilities. C. Relying on cluster-specific monitoring tools without centralized oversight. D. Using Tanzu Mission Control exclusively for user access management, ignoring cluster states. Answer. Correct answer. C. Explanation. Tanzu Mission Control is designed to provide centralized management for multiple Kubernetes clusters. One of its key features is the ability to enforce governance policies consistently and automate compliance checks, ensuring clusters conform to organizational standards. This centralized approach improves efficiency and reduces operational risk compared to isolated monitoring efforts. Question 23. From the perspective of container image management, why is it critical to implement a robust image tagging strategy in a SICT pipeline? A. It enables tracking and deployment of specific image versions, ensuring reproducible builds and rollbacks. B. It allows images to be stored only locally on developer machines. C. It removes the need to scan images for vulnerabilities before deployment. D. It simplifies image building by avoiding metadata and version control. Answer. Correct answer. A. Explanation. A consistent image tagging strategy assigns meaningful and immutable tags, e.g., version numbers, commit hashes to container images. This practice supports traceability, facilitates rollbacks to known good versions, and integrates tightly with SICT pipelines for automated deployments. It is essential for reliable application delivery and auditability in modern Kubernetes workflows. Question 24. Within the framework of application modernization, how does adopting a microservices architecture impact fault isolation compared to monolithic designs? A microservices increase the risk of cascading failures by tightly coupling components. B. Microservices require all components to restart simultaneously upon failure. C. Microservices reduce fault isolation by sharing common runtime environments. D. Microservices improve fault isolation by encapsulating functionality, limiting failure impact to individual services. Answer. Correct answer. D. Explanation. By decomposing applications into loosely coupled independent services, microservices architecture confines failures within individual components. This isolation prevents widespread outages, enhances resiliency, and enables quicker recovery, contrasting with monolithic applications where faults can propagate and impact the entire system. Question 25. Considering the evidence from Kubernetes networking, what is the primary role of a service of type cluster A to expose applications externally through a load balancer, B to provide an internal stable IP address that enables communication between pods within the cluster, C to allow access to services via external DNS resolution, D to create a direct VPN tunnel between clusters for cross-cluster communication? Answer. Correct answer. B. Explanation. A cluster IP service allocates a stable internal IP address accessible only within the Kubernetes cluster. It facilitates reliable communication between pods and services without exposing the service externally. This internal routing is essential for microservices interaction and maintaining secure network boundaries. Question 26. During the process of deploying applications with Tanzu Kubernetes Grid, what advantage does the integration with VMware vSphere provide? A. It enables automated container image building using vSphere APIs. B. It allows Kubernetes clusters to leverage vSphere's robust virtualization and storage features for enterprise-grade infrastructure. C. It removes the need for Kubernetes control plane components. D. It limits deployments to single-node Kubernetes clusters. Answer. Correct answer. C. Explanation. VMware vSphere integration with Tanzu Kubernetes Grid provides a reliable, scalable infrastructure foundation for Kubernetes clusters. This integration enables features like VM-level security, persistent storage management, and resource optimization while allowing Kubernetes to run containerized workloads effectively on proven virtualization platforms. Question 27. To what extent does the use of config maps enhance application flexibility in Kubernetes environments? A. Config maps decouple configuration from container images, allowing dynamic updates without rebuilding images. B. Config maps embed configuration data directly into container images, ensuring consistency. C. Config maps replace environment variables by hard-coding configuration values inside applications. D. Config maps enforce immutable configurations that cannot be changed after deployment. Answer. Correct answer. A. Explanation. Config maps allow Kubernetes users to manage configuration data separately from container images. This separation enables applications to receive updated configuration without needing image rebuilds or redeployments, increasing agility and simplifying application lifecycle management. Question 20. How might one explain the role of Tanzu Application Catalog in an enterprise application modernization strategy? A. It provides a centralized repository of curated, pre-built, and continuously maintained open-source container images. B. It acts as a deployment automation tool replacing SICT pipelines. C. It offers cloud-native logging and monitoring capabilities for applications. D. It functions as a Kubernetes control plane component managing pod scheduling. Answer. Correct answer. D. Explanation. Tanzu Application Catalog is a curated collection of vetted, enterprise-ready container images sourced from open-source projects. It supports modernization by offering secure, tested images that reduce development and compliance risks, enabling faster, safer application deployment. Question 29. From the perspective of Kubernetes storage, why are persistent volumes (PVS) critical for stateful application modernization? A. PVS provide ephemeral storage that is deleted when pods terminate. B. PVS, abstract storage provisioning and lifecycle management, allowing applications to retain data beyond pod lifecycles. C. PVS, replicate all container images across nodes automatically. D. PVS, replace the need for container image registries by storing application binaries. Answer. Correct answer. B. Explanation. Persistent volumes provide stable, abstracted storage resources that persist independently of pod lifecycles, enabling stateful applications to store and retrieve data reliably. This persistence is essential for modernizing applications with databases, caches, or other stateful components within Kubernetes. Question 30. Upon closer examination, what does the immutable infrastructure principle imply in VMware Tanzu's modern application deployment? A. Infrastructure components are updated manually without automation to avoid mistakes. B. Infrastructure is treated as disposable, replaced with new instances rather than modified in place, ensuring consistency and traceability. C. Infrastructure configurations are stored only on physical devices, not in code. D. Infrastructure changes are applied directly to live clusters to minimize downtime. Answer. Correct answer. C. Explanation. Immutable infrastructure means that instead of modifying existing infrastructure components like servers or containers, new instances are created with the desired configuration. This approach reduces configuration drift, improves reliability, and makes deployments predictable and repeatable, aligning with best practices in VMware Tanzu environments.